Hello friends, this is a course on speech signal processing and my name is Umesh. I'll be taking about 12 into 3, about 36 lectures. Many of the material that we are presenting today or in the next throughout this course is based on a lot of work from our lab itself and from our PhD and master students. So you can see in many of the slides I will be actually crediting my PhD student. For example, Matilda has prepared a lot of the slides today, and this is a collaborative work, right, with my students. And so what is this course about? So this course is about basically giving you an overview of speech signal processing, right? I will be going through the basics because it's a signal processing kind of a course. Initially, at least, you'll have to have some basics. Therefore, we'll talk a little bit on the speech signal itself and signal processing aspects. Very few lectures just to give you some background, and we also need a lot of statistics, right? So some brief kind of overview on what is relevant for this particular course. Then broadly there are 4-5. This is basically an applied course, right? So in today's world it's more like an applied machine learning, applied deep learning kind of a course, and therefore we will talk about some of the typical applications of this technology, speech aspects of it, and through that a lot of the ideas about the speech signal, what is important, what is not important, is what I would like to communicate. And this is a practical course. At the end of this course, I hope you will be fairly comfortable with handling many of the ideas that are relevant for speech, and maybe build systems on your own, right? There are a lot of toolkits available, and per se, because this is a machine learning deep learning kind of thing, it'll be good if you practice this out of class using Python, and there are many of course good libraries like the PyTorch is there, TensorFlow. So and speech itself has specific toolkits like ESPnet and Kaldi, and these are used widely all over the world. So this is something that you will be made aware of. And there are 3-4 broad applications that we'll talk about. One is called automatic speech recognition, the other is text to speech, and the third is speaker verification. So we will spend quite a bit of time in each of these, and through this 3 applications we will you will get an idea of what is this whole course about, what is this whole technology about, and many of this have commonality with natural language processing or text processing or computer vision. So these ideas generally get borrowed from one another, and so you will see that if you are familiar with a NLP kind of material or a computer vision kind of material, you will be seeing a lot of similarity, and what you learn here is also relevant in many other machine learning, deep learning kind of applications. Okay, so we are going to follow the typical BSc data science kind of an evaluation scheme. So there are going to be 2 mid-sems, okay, each carrying a weightage of about 25%. I think the final should be 50%. I said I've written here 40. I'm assuming that I'll at least have some 10%. We will discuss it, towards the middle of the course. In the slides, we will again make it a little more clearer whether we can have some hands-on 10% evaluation. Okay. Otherwise, it will become 50% final evaluation, and these, of course, are going to be held in TCS centers. So, what is the primary purpose of speech, right? I mean, why do we speak, right? And the primary purpose is we want to communicate, right? We want to send a message, right, or give information to somebody, right? So that's the primary purpose. That's the reason why I'm speaking now, right? So that you can get an idea about what is speech signal processing and so on. So speech is fundamental, right? It is a means by which we communicate with each other, right? And therefore we need to have an idea of what we want to say. So when we actually speak, the first thing we do is actually formulate the message in our brain, right? about what we want to say, right? What is the message we want to say, right? So for example, if I'm sitting, like now we are, let's say it's about lunchtime, right? And I'm sitting in the lab along with some of my colleagues, right, or friends. And then I get up and said, I want to ask, I am hungry, so I want to ask, do you want to join me for lunch, right? So that is the message that I want to give, right? But I can communicate that message in many different ways, right? So the words that I use are going to be very different. I can say, do you want to go for lunch? I can just simply say lunch, lunch. And you can see by the voice, so in spoken language, there is no punctuation, right? So by the way that I say lunch, that's a question, right? So I'm increasing what's called the pitch, and that is basically communicating that I'm asking a question. Lunch, like lunch, do you want to go for lunch, right? Or shall you go for lunch? Or are you hungry? That itself implies that, because it's lunchtime, you are asking him whether, shall you go for lunch? And that's not necessarily only in English, right? Most of us speak many languages, right? We are at least bilingual or trilingual, right? We have a mother tongue. We most often in cities can, many of us can speak English, to some extent another language, maybe Hindi, or if or some neighboring state language, right? So I might formulate the same message in multiple ways. Like, lunch jana hai kya? My Hindi is not good, but generally that in Hindi means, do you want to go for lunch? Or if I'm in a Tamil kind of a background, I might say sapdalama, sapda polama. There are so many ways that I can communicate. So the message is very simple. Do you want to join me for lunch? But when I speak, right, I can formulate this message in using very different words, using very different language, right, many different languages. And so the whole purpose of speech is just this, that I want to communicate something to the other person. And obviously in speech, I need the other person, right, the listener, right? There has to be, what is the purpose if I just address a wall and nobody is there, right? My speech is, totally useless, because if I'm not recording or doing anything, right, I've just spoken to a wall, I'm not going to get any response. So the listener, so that is the feedback. I am communicating to somebody, right? So there is an important part. There is a somebody or someone sitting the other side who needs to receive this information. So speech, when I speak, there is the aspect that I am communicating or I am generating a message, but there has to be a receiver for the message, somebody who can listen and then act upon that message, right? So we have both entities that are very important, right? And therefore, speech is essentially started by formulating something, right? I think I want to communicate a message, and so that message is formulated in the brain, right? After I formulate the message in the brain, then I think, what words will I use? We do it effortlessly, but we actually are saying, what words would you like? What language would we like this message to be communicated? And then once I sort of formulate this message using words of a particular language, then my brain actually moves my mouth to actually produce these different words, right? So when I say sapdal polama, my mouth is moving in very different ways compared to lunch jana hai, or do you want to go for lunch? They are all different languages, different words, and therefore we have the mouth movement which is actually controlled, right? I mean, the nerves are there, they are sending the basically messages to the muscles of my mouth, which then move appropriately and I communicate the message, right? And that comes out of my mouth. And because speech basically is a sound signal, right, you have compressions and rarefactions, right? And this, of course, is going, as I said, the primary purpose of communication is I want to send a message or an information to somebody else. So there has to be a receiver. So this message, if the person happens to be in the same room, is something that will go and hit the ear, right? So it's going to be picked up, the rarefactions are going to come to the ear, and the ear has something called the basilar membrane, right? Which, so you would have heard about the eardrum. So the eardrum vibrates, and that activates something called the nerves of the basilar membrane, and then the nerves take it to the brain, and beyond that it's still not very well understood. But we as humans can understand that, okay, this person is telling, shall we go for lunch, and okay, I agree. and therefore I will say, we are, let's go, okay, something like that I'll say, right? So that is the entire loop. So I communicate, and then the person responds, and the loop gets completed, right? So this is the primary purpose of communication, and speech is a basic interface or basic way that I'm going to communicate, right? I could have communicated by typing on my WhatsApp message, or sending a SMS, or sending an email, right? But text, often speech is much more richer, and we do have information about the speaker, the gender, his emotional state, many things that are not obvious in text, right? So if you just type a text and show it to somebody, they may not be able to easily find the gender, they may not be able to find out the emotion, right? I mean, a lot of things, sometimes that's why text is very bad, because you may mean something, right, but the interpretation by the reader is sometimes very different, right? So text is another way, but speech is usually the most easiest way of communicating, right? So so this is what we call as a speech chain. So there is a brain that formulates a message, right? And then and once it formulates a message, and also what language, what words to use, then it sort of triggers the neurons, which communicates to the muscles, controls the muscles, and that moves my jaw, my lips, and so on. And then the speech signal comes out, which is basically a sound signal. Then this is, as I said, you need the other end. So this has to travel, right? If it's in the same room, it's going to travel in the air, and therefore then the ear receives it and completes it goes up to the brain of the listener, and this completes the chain. Okay. So there are terms that I will be using, which basically linguistic, physiological. So linguistic is a message basically which I'm going to frame in terms of the words, right? The linguistic information. Physiological, because physiology, right? I'm going to be moving certain parts of my mouth, my tongue, and so on. So there is a physiology aspect that is involved. Then the air picks up this vibrations, right? So that is the acoustic aspects, right? Again, it hits the eardrum, so there is a physiological aspect to it, and then finally the brain interprets, which is the linguistic aspects. Okay, so these are terms that we may use, and you should know what they mean, right? So so one of the first applications for speech was that you want to preserve speech for posterity, right? So I want to record somebody whom I love for a long time, right? But that is one of the primary reasons we started, right? So recording and storing speech was one of the first goals. But later, immediately humans are always, want more and more, right? That's how we progress. So if I am able to communicate to somebody in the room, that's very good. But often the first requirements in olden days itself was a necessity that how do I speak here and communicate to somebody who's 100 miles away, right? Or 100 kilometers away, right? How do I do that, right? I mean, that was one of the grand challenges, right? So we had this messaging through horses, right? Relay of horses sending and so on, right? And again, that was a written sort of a information, right? One would ideally like the voice itself to be transmitted over hundreds of kilometers, right? And received as it has been spoken by the speaker, right? So we wanted to exactly capture that, and this is what these two aspects of storage, which is also sometimes we want to store in an efficient manner, right? I want to use as less hard disk as possible, as less bits if I'm communicating, right, as possible. So the whole idea of transmission over long distances and storage was one of the primary applications of speech, right? And therefore we will see. And in today's world, we normally use computers, and they are all digital computers, right? Even your mobile phones basically have chips. They are all digital chips, right? That we are dealing with. So, but the speaker, when he speaks, the sound that comes out is continuous, right? So these are compressions and rarefactions which are picked up by your microphone, right? So there's a transducer sitting in the microphone, right? And therefore it's a continuous time waveform. We will see that in the DSP aspect of this course, and that has to, but computers can handle, digital computers can handle only numbers, right? they can store these numbers in these registers, memory registers, with finite number of bits. So it's only a finite precision that we can handle, right? So so there is even though your floating point or whatever it is, it's only to a certain degree. There is some amount of quantization that will take place. So first we have to convert this continuous time signal to something that the microprocessors, the CPUs, the GPUs, etc. can handle as numbers, right? And so the conversion is very important. And then we can do some more fancy coding on top of it, right, to reduce the number of bits and so on. So there's a compression, coding kind of aspects, and then we can send it across the channel. So in some of the typical channels you have seen is your telephone wire, right? So in landline, that is a medium through which speech was sent across large distances. In today's world, of course, air itself is a medium, so we are doing wireless communication, right? And so this is sent as either data or voice signal itself, and it's received at the other end. So one of the first primary kind of application of speech, apart from just speaking and communicating, was how can I store it efficiently and how can I send it over large distances efficiently, right? Some of the other applications include, one of the grand goals about 100 years, 150 years back was, can I talk to machines, right? Can machines talk back to me, right? So these are typically two broad applications in today's world also. So one is called text to speech, right? So whatever information that I have, right, that the computer generates or wants to communicate back to the user, right? You want it not as something that appears on the screen. You would like hands-free kind of thing. You would like the computer to talk back to you, right? And so that is called text to speech. So if I have a text formulated, then can I synthesize it in a natural human voice? Okay, that's one of the big goals. And the opposite is when I speak, right? Can I communicate to the machine in some way, right? And therefore we need the opposite. I am producing the speech signal, but now I want it to be converted to text so that the machine can process it and act on the text, right? Or can I, when I speak, can the machine understand not what I'm saying, but who am I, right? In speaker verification, biometrics, right? For a banking kind of a thing, just by speaking, the banks, if I have a good speaker verification software, it double checks, oh, is this the person who is actually claiming who he is or she is? And then, if I'm comfortable and I'm fairly confident that I don't otherwise ask for a PIN number, an alternate OTP and so on, right? So there are many applications that you can have with this technology, okay? So these are some of the basic important applications in today's speech technology. One is, of course, efficient transmission and storage, right? The other is, of course, what we call speech recognition or automatic speech recognition, ASR, or sometimes also called speech to text, STT. That is, when I speak, can I automatically convert this to text, right? The opposite direction is, if I generate text, can I produce human voice out of it, right? Can I speak what has been written, right? That is speech synthesis, or also called text to speech synthesis, right? So, TTS, right? So, then there is a verification and identification. Can I identify the speaker? There's a long, I'm recording something on the border, right? And I want to know if certain keywords are being produced, right? Something like, or is a person specifically talking? Is there somebody who I know is harmful or is doing something that might harm the country, right? I want to recognize whether he has spoken anywhere in this 100 hours of recording, 1,000 hours that I have recorded on the border, right? I want to I cannot manually check all the 1,000 hours to check whether he has spoken. Is there an automated way to identify whether he has spoken and so on, right? That's where verification, identification for banking and so on comes. Then there's diarization. So when I'm in a meeting, right, you automatically, are able to filter out, right? So, he said this, she replied like that, and third person interjected like this and so on. So you have this information when these different people said what, right? But when you're doing speech technology, if you just do ASR, it's going to just produce text without telling who said when and what and so on, right? So diarization is very important in meetings. Then you can create good transcripts. The news anchor said this, in response to that participant A replied like this, and participant B interjected and said no, that's not correct. So you have a nice way of presenting that information, which is easier when you're reading and understanding what happened in the news interview, or in the meeting, or whatever it is, right? So even if you're not present, right? And then of course we are all live in an environment where there's going to be a lot of noise and other aspects, right? And so we would like the quality of the speech to be improved, right? And now we have to be very careful. When I improve speech quality, I'm looking at it from a perspective of this listener, right? And like the eye, the ear also has many deficiencies. So we are worried about what's called the perceptual quality. If I am not able to hear the noise as a human being, right, then that is what is more important, right? So cleaning a signal does not mean that I just remove what is the noise aspect. Whatever I remove, if that is important and that is getting removed, that is the primary purpose. There might be, like for example, right, there are certain frequencies that as a human I cannot hear. A dog can hear, but I cannot hear. If I'm not removing those frequencies, it is not at all relevant, right? That frequency is noise, it is present there, but as a listener I am not going to actually hear it, right, because of the deficiencies of the human ear, and therefore I don't even bother about cleaning that aspect. So we should be smart in all our we as engineers, especially as researchers, as scientists, right, as practicing scientists, engineers, so on. We should do what is relevant, right? One is, of course, the goal is, can I solve this problem, however difficult it is. Sometimes we have to only worry about what is it really important problem to solve, right? Is it important at all, right? I mean, if that frequency is not even heard by humans and it is there, why bother about spending some more additional hardware, software, everything, trying to clean up that, right? Because anyway, the human is not going to be bothered by it, okay? So these are aspects that you have to do or understand when you design systems, when you specify systems, right? And of course, a large part of this technology is also towards the differently abled, right? So people who are spastic or who have paraplegia or something, right? Can they speak and get their work done? Can they, control devices through voice, right? So many applications are there, okay? So that's just to give you a background why these speech has so many applications, and why it's an everyday part of our life, right? Speech, and that is also an issue that we are often unforgiving. What do I mean by that? Because we do it so effortlessly. When the machine makes mistakes, right? These are all statistical, probabilistic kind of ideas. It's bound to make mistakes, right? But whenever it makes mistakes, you would think it's a stupid mistake. I know, how can it make such a stupid mistake? But you should understand, this is a machine. Is when it started off, what was it? It was just a blank hardware, right? Nothing was on it, right? Then you write some algorithm, some software to make it intelligent, right? Nothing can compare with your brain, right? I mean, it's such a super computer sitting there, right? So you cannot expect machines to compete with you, right? I mean, we are superior beings, right? But there are lots of things that they can do efficiently that we may that is not our strength. I mean, there are I can run hundreds of, I mean, it can run 24/7 without tiring, right? Whereas a human being after 8 hours will tire, right? So if you want a call center, right, you put a human being, an agent, he is going to tire. So you need 3 shifts. But if an automated call center is there, then obviously it will run 24/7 and will not get irritated. So there are many advantages to modernize, I mean, having these technologies. But to say that they can replace human beings is not the correct way of looking at it, right? They are assisting, or they're making our lives better, okay? So that's the way you should look at it.